Now that we know a little bit about integration or anti-differentiation, which is doing the derivative backwards, and we learned some of the traditional rules, like you can pull out constants, we learned the power rule. Now we're going to move on to a new section, 5.2, which is integration by substitution and the general power rule. This is one of my favorite sections to teach for integration rules. It allows us to integrate some more complicated functions by using a technique that we've used several times in college algebra and trig, and already we've used this semester as well. It's called U substitution. Works really, really well for this section. Okay, so we just want to remind ourselves what the power rule was. The previous section, it says anytime you have x to the end, if you're going to do the integral or the antiderivative, you raise the power by 1 and then you divide by that same number plus 1. And then again, never forget that plus c, which is your arbitrary constant that you're adding there, constant of integration. So it says, in this section we will study techniques to find more advanced derivatives. To begin, consider how you might find the antiderivative of 2x times the quantity x squared plus 1 quantity cubed. Again, so what we would be finding is the antiderivative or the integral of this with respect to x. So the question is, what do you take the derivative of and get this as the answer? Well, what you might notice is if you see x squared plus 1, that's the inside, and then look to the outside, you see the 2x. If you notice, I circled the x squared plus 1 in blue, and the green is the 2x. If you take the derivative of the blue, you get the green. And that's going to be key to what we're doing with our U substitution is how can we figure this out, okay? So they give us some examples to remind ourselves, and it says the derivative with respect to x of x squared plus 1 quantity to the fourth. That's where you have to use the general power rule, where you drop the power, which would be 4, keep the exact same thing to the power minus 1, so that's the x squared plus 1 quantity cubed. But then you have to remember the derivative of the inside, and the derivative of x squared plus 1 is that 2x. So what that tells us then is if we find the antiderivative of the right side, we would have to get the left side, which is the x squared plus 1 to the fourth. So all we're going to do is take the chain rule that we have been doing the entire time, except we're going to learn how to do that chain rule backwards. Okay? So it says the key to the solution is the presence of the factor of 2x in the integrand. In other words, the solution works because 2x is precisely the derivative of x squared plus 1. So we're going back up to that original problem up there. It says letting u equal x squared plus 1, you can write the following. U cubed and then 2x dx they call du, and then they change it into an integral in terms of u instead of x's, but then they back substitute. So let me work you through the problem the way that I like doing it. So let's consider the original problem, which is the integral of 2x times x squared plus 1 quantity cubed with respect to x. So what's the idea? Well, the idea is we're going to let u be whatever the higher power of x is. I like to call it the inside function. So here I'm going to say let u equal x squared plus 1. Then what are we going to do? Well, we're going to take the derivative with respect to x of both sides. The derivative with respect to x of both sides of the equation, u equals x squared plus 1. So on the left, we would simply have du dx, and on the right, we would have, well, the derivative of x squared plus 1 is 2x. So I do it a little bit differently than the book does. The book solves for du. What I do is I solve for dx. So to solve for dx, I'm going to multiply both sides of the equation by dx. I get rid of my dx's on the left. And then I'm also going to divide both sides by 2x. So what would happen if I did both of those in one step? Seems to me I would have on the left du over 2x, and on the right I'd have dx. So what do? At this point in time, you go back to the original integral, and you're going to plug in what the original u was. U was x squared plus 1. And then you're also going to substitute for dx. So wherever you see dx, you're going to plug in the new dx. So what this does is this should get rid of all the x's in the original problem and get everything in terms of u. So let's look at this. We'd have the integral of 2x times, instead of x squared plus 1, I'd have u cubed, and then instead of dx, I have the du over 2x. So again, what I've done is I substituted in for u, and I substituted in for dx. Notice what happens, the 2x's simplify here, and I'm left with the integral of u cubed du. Now that my variable and my differential match, I'm able to integrate this. Using the power rule, the integral of u cubed would be u to the fourth over 4. Then we need that plus c, right? But now what we have to do is we have to go back and remember what was u. Our original problem started with x's. We need to end with x's. So I need to back substitute for u. Well, u was x squared plus 1. So what we have then is x squared plus 1 raised to the 4th power all over 4. You could write that as 1/4, but that's perfectly fine. And then we have our plus c. So the idea should be if I take the derivative of x squared plus 1 to the 4th all over 4 plus c, I should get the original function. Let's give it a try. Let's verify that to make sure we did it right. So I'm going to take the derivative of that. If I take the derivative of my answer, I'd have the 1/4. I'd use the general power rule, so I'd have 4 times x squared plus 1 to the power minus 1, which would be 3, and then I got to remember the derivative of the inside, which is 2x. Notice here the 1/4 and the 4's simplify. So I'm left with x squared plus 1 cubed times 2x. I go back and I look at the original problem. It was x squared plus 1 cubed times 2x. That means I do have the right answer. Again, I didn't find the derivative of plus c because the derivative of any constant is 0. So the answer to the problem would be x squared plus 1 to the 4th over 4 plus c. And that's kind of what they're getting at right here. They got to the u to the 4th over 4 plus c, but you never saw them actually back substitute for u. That's the last thing that they'd have to do in this example. So that gives us the general power rule for integration. It says the integral of u to the n du dx times dx is the integral of u to the n du. Just says just integrate, just like you know how to do. But the one thing you want to do is never forget to back substitute for u. Make sure your final answer is in terms of x's, not u's.